Hello and welcome guys to the first episode of Game Programming Parents inside Unreal and Unity. My name is Kamal Eta. I work for a small indie studio located in Egypt. It's called GameHermits, and tune in for the end of the video to know more about me and GameHermits. Anyways, in this series we are aiming to break down the popular game design patterns um, and how we can implement them inside Unreal Engine and Unity. Before we start this, I expect you to have a good knowledge in C++ or C Sharp and the engine that we are going to use, whether it's Unreal or Unity. Also, I expect you to be a good object-oriented programming thinker because uh, I'm not going to explain every little bit of details in the code base, and I'll try to focus more on the implementation of the design pattern itself. So let's get into it. The first design pattern that we are going to discuss is Service-Locator pattern. It's in the mid-ground of singletons, between singletons and dependency injection patterns. If your game is not so complex that it needs to implement dependency injection, and at the same time singletons are very lame and they can cause you a lot of headache when maintaining your code, Service-Locator pattern is the design pattern suited for you. So in short, let's say you have a class, you have a lot of classes in your code base and you want to access your services anywhere in the code base. Now the simplest way to do this is to implement these services as singletons. However, singletons are very hard to maintain and could cause you headache so quickly because let's say for example you want to make a unit testing and you have a service called Game Manager. Now you have to modify the Game Manager to suit your test cases and then modify it back once you are done with your test cases to the production code, and that's just a lot of work to do for nothing. However, Service-Locator pattern aims to resolve this issue by creating a medium between your code and the services that you want to implement. And the way we will implement this will allow us to give you our code very flexible means to kinda inject any service that we want uh, and tell the locator that this is the service that we want to use instead of service B, for example. And even if none of these services are there, we still are going to have a null service uh, that basically returns nothing and does nothing. However, it does not return null, so that the game doesn't crash or run into null errors. Alright, so let's see this in action. So in here I have an empty C++ Unreal project, and let's go ahead and create our classes. For the sake of example, we will create a service called Game Manager, and this Game Manager will have its own game world, not this world, but a game world that consists of actors that we are expected to react to inside our code. And we will implement a function called findGameActor or findActor by tag that just loops through our game actors array and finds the corresponding actor based on the tag that we pass in. So let's go ahead. We will create this from none and we will call it by Game Manager because this is going to be our interface. Compiling. Now, just to be sure, to deliver all the information about Service-Locator, its biggest flaw is that it hides the implementation or the dependency between classes. which is a very dangerous thing to do, especially for production code. Uh, However, if the game isn't big enough, for example, let's say, for example, up to 5 programmers are working on it, and there is enough documentation, Service-Locator pattern can be a very good design pattern that gives flexibility and robust to our code base without having to implement complex code inside our game, unlike dependency injection design pattern, for example. Alright, let's jump into it. First of all, we'll include the actor class. Actor. This is a pure C++ interface, so virtual find the actor, find actor by tag, and we will give it a const f string tag, and got semicolon, virtual void register actor. What this will do is just will add our actors to our game world. So actor, and we don't want to forget to turn this into virtual. Alright, let's compile and see. Great. Now we want to implement this interface, so let's go ahead and do the null game manager, which is going to be our default interface, our default service. So if anything goes wrong, if we couldn't construct our main game manager or any game manager properly, this null game manager is going to take effect, and it basically does nothing, just to prevent any game crashes or null errors. So let's include iGame manager, click iGame manager. Here we are going to implement the interface, so the actor find game find actor by tag, and it just returns a null pointer. Not to be confused, we are returning null pointer, so this function returns null pointer, but that doesn't mean that we are going to return a null service. So yeah, void register actor, and this will pass in actor and just does nothing. So like that, we are guaranteed that we will not run into a null game manager, a null service error, or the game will crash if anything would happen. We'll see this in a bit. Alright, let's go ahead and implement our actual game manager. So let's call it, for example, main game manager. Takes a little setup in the beginning, but then it's all fine. Alright, let's go ahead and see our game manager. So first include iGame manager, inherit from it. Alright, so let's go ahead and implement this interface. find actor by tag const f string tag and void register alright, and we'll need a private section here. It's going to be our game world, so TRA actors our our game world, like this. Let's go ahead and create definitions for them. And alright. So the first thing we'll do is implement find actor by tag. So if our game world num is bigger than 0, so if we have any actors in our game world that we want to interact with, we will loop through this game world. So our game world num, and if the IntelliSense is just buggy in the Visual Studio. So if our game world of I tags of 0, so the first tag, for example, dot toString equals the tag that we give it, then return our game world of I. So if we do not find any game actors with the same tag, we'll just return null. Of course, you can customize this, you can do whatever you want in the service that you want, but this is just as simple as it gets for the sake of example. In register actor, we will just say our game world dot add actor. Alright, let's build this and see. Great. Now we will create the Service-Locator class. This is also going to be none. So Service-Locator and what this does is, this is our main factory, this is our main guy that we're going to locate which service are we going to use, whether it's null game manager, main game manager, X game manager, Y game manager, etc. So first we will include all the services that we want. So include, oops, can't get this right, I game manager. We'll also include game manager, main game manager, and include null game manager. In the service locator, we will have two basic functions, the initialize and provide. Initialize is just initializes service locator in our game constructor, and this initializes all our services to their null services versions. And in the provide, we will use this in the game constructor so that we provide which service, which implementation of our services that we want to use, which will give us a huge flexibility. So let's go ahead and do that. Void in finish, let's call it init. Alright, and it will just have nothing. In void provide, this will take game manager, and as you can see, you can have as many overrided provide for your services. So let's say, for example, you have 3 services, you can have 3 overrides. Each one of provides just have different parameter depending on your services. And in our private section, we forgot to do something, static. So we can call it anywhere from our game code, and also static game manager get game manager. This will just return the current game manager that we implemented. Alright, in here we will have 2 services, so static game manager, game manager, oops, so this is like this is the game manager that we are going to deal with, whatever the implementation is. And the second one is static null game manager, which is going to be null game manager, which is going to be our default. If anything happened, it still gets called. So let's go ahead and see how we can implement this in our CPP file. So first, game manager Service-Locator, and we will initialize it as null pointer. And for this null game manager, alright, we initialize our statics. Now in the initialize, we will simply say game manager equals null game manager. This is what I'm talking about. So so we have a reference to an empty game manager that does nothing, and this is by default is our game manager. And here we will initialize all our services the same way. So inside provide, we'll just say Service-Locator game manager equals game manager. Just noticed they are the same. This will set our game manager to whatever we provided and whatever implementation that we want, so we can pretty much do an implementation just to unit test and make it the game manager of the scene of the game, even if temporarily, which is a great feature of this design pattern. And here we will just return game manager. Great, let's build this. What a noisy night. Nice. Now to test this, we will make a game constructor. Now I could do this inside a game instance, but just for the sake of simplicity, let's just do it an actor and just make it an empty actor in the scene. So game, let's say my game constructor. constructor. Alright. God, I hate these red lines. Alright. Here we'll just leave everything as it is. Just include service locator like this. Alright, so inside here we will provide the service locator of the implementation that we want. So let's go ahead and do that. Main game manager. This is the implementation that we want to be using. Game manager equals new. Actually, game manager equals new main game manager. Right? Okay. Then we will say service locator initialize. This will initialize our service locator. This is very important. We cannot leave this undone. Then service locator provide, and we will pass in the game manager. And so now we've provided game manager to our service locator. However, when this pointer goes out of scope, we could have memory leak. So we need to null it out. So game manager equals null pointer. Can't get it right. God. Game manager equals null pointer, and then delete game manager like this. Now we've implemented the service locator successfully. Let's build this. Nice. The last thing that we want to do is just make a small actor component that will register the actors that we want to interact with. Let's call it, for example, self-register. Alright. I don't know why it's doing like this. Alright. So in the begin play, we want to include service locator, and in the begin play we will just do service locator get game manager, whatever our game manager is, and register actor, and we will give it this. Actually, get owner, so we can kind of register our game. And let's say, for example, if Service-Locator, oops, Git Game Manager, let's do this here actually. So a actor equals this code here, find actor by tag, and we will give it, let's say for example, tag, what a name. And here if actor equals git owner, we will just print out some log. So ue log temp warning text all working fine. Let's build this. Of course, it's just for the example, for the sake of example, it's a very bad practice to have a for loop inside tag component. Let's just go and try this out. So let's take this ground for example. First we will add self-register, like so, and we want to add, we actually want to implement footprint out of this, so whatever. And I'll just drag it here anywhere. And in this, we want, in the actor, we want to add in a tag and call it tag, like so. Let's play. All working fine. So here you go, guys. This is how you implement Service-Locator parent in its simplest form. You can of course tweak this as much as you want. As I said, it gives you a great robust and flexibility in your code base to just basically, if you need any singleton, just use Service-Locator. And if Service-Locator, if you have a lot of dependencies and you have a big team, then consider either document your code base very carefully, or use dependency injection, and we should be doing this later in this series. For those of you who want to know more about me, you can follow me on Twitter, find me on Facebook, and or find GameHermits on Facebook. I'll leave links in the description below. Also, hit that ring button and subscribe for more videos, and let me know in the comments what you thought of this video and what you think I should be doing to raise the quality of these videos, and if I should do more or not. Thank you guys, and goodbye.